students, welcome to Pankti's tutorial. This video lecture would be about how a convolution function is derived and how it is implemented on discrete time signals and what is the actual meaning of convolution. Before coming on to the derivation of the convolution function, we all know how to represent a discrete time function using time shifted impulse signal. For those of you who do not know, I have provided the link in the description part. So this is how any discrete time function is represented as a time shifted impulse signal. Now here it is given as summation f of k del n minus k, where f of k represents the value of this discrete time function at kth time instant. Now suppose we have a system and the system that we consider is an LTI system. LTI means linear time invariant system. So this system will be linear and it will also be time invariant. Now to this system, when we apply the input as an impulse signal, the output that we get is this h of n, and it is then called as the impulse response of the system. To the same system, when we apply the function fn, which I am considering any discrete time signal, now when I apply f of n, I am naming the output as y of n. Now with convolution, what do is, we try to find out y of n using f of n and hn. Now when we consider our LTI system, if I apply the impulse signal as the input, the output that we get is called as the impulse response of the system and it is denoted with h of n. Now to same impulse signal, I am applying with some time shift. So this impulse signal is del n minus k. The system that we have considered is linear time invariant system. So if there is some time shift or some time delay in the input signal, the output value will also get delayed by the same amount. So we have the output response hn minus k, which is also delayed by the same amount with which the input is delayed. This is happening because the system is time invariant system. The next property I can apply on this is, when I multiply this del of n minus k with some constant value, the output should also get multiplied with the same constant value because it is a linear system and it will satisfy the property of homogeneity. So when I am multiplying with f of k, which is the value of the function fn at kth time instant, the output will also get multiplied with f of k because it is a linear system. The next thing that I do is, I apply the summation here. The summation function as it is gets transformed to the output side because it is a linear system that would also satisfy the property of superposition. The function that is on this side, summation k is equal to minus infinity to infinity f of k del of n minus k, can be written as fn convolution del n. So that would mean that the function that is on the other side can also be written as fn convolution hn. Now this function that we have here is actually what? It is f of n only. So this f of n convolution del n is fn. That would mean whenever we are convolving any discrete time signal with a discrete time impulse signal, the output will be the same signal. There will not be any change in the signal when it is convolved with a unit impulse signal and it will remain as it was earlier. But this function fn, when it is getting convolved with the impulse response of the system, this will give us y of n, that means the response of the system when we are applying f of n as the input signal. So y of n is given as fn convolution hn. Let us now see how this gets transformed to this function and what is the meaning of this function and what all operations are applied onto it. So we have y of n equal to fn convolution hn. The mathematically it is given as summation k is equal to minus infinity to infinity f of k h of minus k. Now the function that we had originally were fn and hn. This hn was the impulse response of the system and this fn was the discrete time input that we are applying to this system, and we want to find out y of n, and to find out y of n, the formula that we are getting is this. Now dummy variable k. So the function that we get is f of k. Similarly, the function hn is on a variable which is n, and when we change this n to a dummy variable, we get it as h of k. Now on this h of k, we apply time reversal operation to get h of minus k. So when we have obtained this time reversed signal which is h of minus k, what I want to do is, I want to keep shifting this h of minus k and multiply the values with fk so that I can sum up all the values that I get with each shift. So for that, I need to apply the shifting operation on this variable k. Therefore, I'll substitute this k as k minus n because this will then give me the shift. When k is substituted here as k minus n and open up the bracket, the result that we get is h of n minus k. This n would keep giving us the shift, and I'll keep multiplying the signal with fk and will sum up all the values to obtain y of n. Let us now understand the literal meaning of what is yn and how it is obtained with convolution and what is this convolution function working as. So when we are doing convolution, what we are doing is, suppose we have a function f of n and this function is with the variable n. This is then changed to a function f of k with dummy variable k here. The function is changing as it is. There is no change in the values of the function. Similarly, the other function that we have is hn. This function is on the variable n and then this changed to a dummy variable with k. So the function that we get is h of k. This h of k function is then time reversed, so it is flipped along the y-axis. So this is the function that we get as h of minus k. So when we are doing convolution, what we do is, we keep shifting this h of minus k over this f of k, and when we are shifting this h of minus k over f of k, we get some overlap value, and that overlapping value is obtained by multiplying this signal with this signal. And with each shift, we'll get some overlapping value by multiplying this signal and this signal. And at the end, for convolution, we add all those overlapping values. So for discrete time signal, convolution is defined as, it is a summation that displays the amount of overlap of one function when it is shifted over the other function. To understand it more, we'll do some more numericals on convolution for discrete time signals.